All right, this is going to be the first of many videos. Feel free to pause as you need and also find all these notes. These are actually so far the first 3 sets of videos, the first 3 weeks of videos, you'll be able to find in that book of notes that Mr. Pasta and I gave you at the beginning of the year. So you can just write them right in there. Or I added this to our folder and also linked it to the assignments in Google Classroom so you can print and then write on your own copy if you like. So we're going to talk about systems of equations. First thing, what the heck is a system of equations? It's 2 or more equations, or in other words, relationships. I should maybe put that in parentheses. 2 or more relationships or equations. So this one is in equation form, but you'll see that we'll have some word problems that are also considered systems. They're just written as words, which are relationships that you can then translate into mathematical equations. All right, so a solution to a system of equations is a pair of numbers that works in both relationships. So it's a pair of numbers or a point that works in both relationships. For example, if I have this system down here, okay, and this system happens to have 2 equations in standard form, remember ax plus by equals c. So if these are our possible answers, a, b, c, d, these 4 down here, how do I check which one is the correct solution? Well, just like if you only had one equation, like before, if that were not there, and you wanted to check if that was a solution, you put the numbers in. Just remember that's x and that's y. But this time, that point, whatever which one you choose, it has to work not in just the first one, not in just the second one. It has to work in both. So I'm going to unerase that. And we're going to substitute into the very first equation. So I'm going to choose this first one. Make sure you put the x in for x and the y in for y. So in this one, if I put it in, I get 5 times negative 3 plus 3 times 4. And let's see if that gets me negative 11. Well, that's negative 15 plus 12. Yeah, that's not negative 11. That's wrong. So it can't be that. All right. So we move on to the next one. When you do this in your homework, you need to do exactly like I just did. Check one. If it doesn't work, X it out, but do not erase it. Don't do it off on the side. This is showing your work. For guess and check method, technically you have to show 3 guesses and checks. One of them can be the correct, but you at least have to show 3. All right, so when you put this in, you put in 3 for X, 4 for Y. That should give me negative 11. Well, that's a positive number and a positive number. 15 and 12. Yeah, that's not going to work. I quit. Not that one either. So now I'm going to try. I'm going to do this one in green. Negative 7. So I'm going to put in 5. Put in negative 7. I wrote 5 when I was saying that. Put in 8 for Y, and that should give me negative 11. So now I've got negative 35 plus 24. Hey, that does give me negative 11. But wait. It has to work in both equations to be a solution to the system. So, I'm sorry I crossed that out already, so I'm going to cross it out now. I need to check that same point, but I have to check it in this other equation as well. So I'm going to put negative 7, right, the opposite of negative 7. Always practice safe math, substitute in parentheses, the negative's there, and then our x that we're putting in is negative, so you have to have negative 7. It's the opposite of x, the opposite of negative 7, plus 3, and my y is 8. That should give me 31. Let's see if it does. Well, negative 7 is 7, plus 3 times 8 is 24. That should equal 31, and it does. That does work. It does give me 31. So it worked in the top, and it worked in the bottom, so this, answer C, is my answer. We can also just see right away that, but since those are both positive, and when I put them in here, I'm going to get a positive number, and I need a negative, so we can cross that one out kind of right away, like we did with the blue one, the part choice B above. Now on example 2, we're going to do the same thing. We're going to check both equations and see if this works. This is called guessing and checking. It's kind of hard to guess and check unless you have some answers to go from, but it's possible to just come up with them. But again, you have to check at least 3 things to show your guess and check works. All right, so I deleted that stuff over there so I had a little more space. so we're going to go ahead and try this first one. I'm going to make sure you put this in for x and this in for y. So I'm going to try it right here in the first one. So 10 equals negative 5 times negative 2 equals, minus 52. That should give me 10 equals, well, that's a positive 10. Negative times a negative is positive, minus 52. Well, that gives me 10 equals negative 42. Well, that's wrong, so I can cross that first one out. The second one, I'm going to put it right in the first equation. It doesn't matter if you put it in the first or the second equation first, but you have to check it in both. So negative 10 equals negative 5 times 2 minus 52. Well, that gives me negative 10 equals negative 10 minus 52. Well, that's negative 62 over here, so negative 10 does not equal negative 62. So that's incorrect. Cross that out. Okay, so let me try this one. If I put in negative 2 for y and negative 10 for x and subtract the 52 at the end of the equation, I'm just substituting into this very first equation still, I get 50 minus 52. Hey, that seems to work. Negative 2 on this side, negative 2 on that side. They're both the same. It gave me the same answer. That coordinate pair, that point, works in that equation, but that does not mean it works in both equations. So it's important that you actually substitute in to the other equation as well. You have to show it works in both equations. And to really, truly make guess and check appropriate, like I said earlier, you really should check 3 different points to show, that you got it right. So I'm putting my negative 10 in and my negative 2 in for x and y. My pen doesn't want to write right now, sorry. That's a parentheses. Equals negative 72. Man alive. Okay, so I get negative 60 minus 12 equals negative 72. Well, yes, it does. Negative 72 on the left side, and you get negative 72 on the right side. And so that point is correct. I have checked 3 values, so I have discarded 2 of them. One of them is correct. I know that negative 2 is my... Now, what if you get a word problem? My friend Algebra bought some shoebles for $6 each and some fronts for $3 each. We started talking about writing these equations, but it says down here shoebles is x, so I'm going to just go right ahead and put that up there, and fronts are y. So if I'm going to write an equation for just that first sentence, I should get 6x plus 3y equals my total cost. Oh, wait, it just says that. My total cost is $144. So this is basically the money I spent on shoebles, the money I spent, or Algebra actually spent on fronts, should give me my total cost. That might be something you want to write down in your notes in words. Now this part is a separate equation. That makes 2 equations in one problem. That makes it a system. Now this is a system of relationships that you can write as equations so that we can do math with them. All right, so the total cost is $144 altogether. She bought 34 items. So in other words, all her shoebles plus all her fronts gives her 34 things. So she might have bought 14 fronts and 20 shoebles. She might have bought the opposite direction. She might have bought 24 and 10. We just don't know. We do know that the cost of each shoeble, the cost of each front, and how many things she bought altogether, and the total amount she spent. So if we have this system of equations, and technically there should be a little, it's called a set bracket. You make an S, kind of a long S, and then a backwards S, and that makes a set bracket. I have fun making those. And so the question's asking how many shoebles and fronts did she buy? So careful, shoebles are X, fronts are Y. And they have them all in the same order in every pair, but these are really just points, coordinate pairs, X and Y. So we just substitute in just like we did. So I want you to try that and see if you can find, I'm going to pause, try them in your equation, and then come back and see what you got. Well, I don't know what you got yet, but I'm going to talk through some of my logic. Before I ever started, I see that this equation here is a little bit easier. So I'm going to talk about that equation. My total number of things that I bought is supposed to be 34 things. So I can't have this. I'm cutting that out because that's 37 things. So basically, I'm in my logic mind doing 17 plus 20. That's not 34. So it can't work. All the rest give me 34. 20 shoebles, 14 francs, possible. 4 shoebles, 30 francs, possible. That's 34. Both things give me 34 things that I bought. 14 shoebles, 20 francs, possible. So we got rid of one. We showed our guess and check kind of off to the side. But then you got to put them into the equation. So let's do that. We know they all work in the second equation already. So I'm going to start at the bottom this time. Why not? 6 times 14 plus 3 times 20, because this is x, that's y, equals 144. I'm putting it in that top blue equation. 6 times 14 is 84. Oops, didn't write the 4. Plus 60 equals 144. By George, that's correct. So that's the answer. You didn't really need to check all of them since we have guess and check. I said you need to check at least 3. I wanted to talk about how, I'm hoping you already found that answer, but I wanted to talk about some logic of how. All right, so on this one, we have the same idea. Umpt bought 7 Mimstoons and 5 Indins for a cost of $46. My friend Frown bought 8 Mimstoons and 10 Indins for a cost of $74. Write a system of statements. So there's 2 questions. There's this about umpt, that's one equation, and this about from, that's another equation. So the first equation with umpt is 7 Mimstoons times whatever they cost, because it says Mimstoons cost, and 5 Indins times whatever they cost. That should give that umpt spent $46. Now, Frown bought 8 Mimstoons for I don't know how much dollars, so we'll multiply by the cost, and 10 Indins, whatever the heck Indins are, and that he spent $74. Now we have a system of equations that's written in equation form rather than relationship or word form, and we can solve it. So Mimstoons, the cost, and Indids, the cost of Indids were X and Y, we substitute in. I'm going to pause. You try, see if you can find the answer. Hopefully you had a chance to check this out and try it. I did get this answer right here, because when you put in X is 3 and Y is $5 in the first equation, you get 21 plus 25, and that is in fact 46. So I get on both sides that 46 on the left equals 46 on the right. That worked there. And in the second equation, I got 24 plus 50 equals 74, which in fact, 24 plus 50 is in fact 74. You get 74 on both sides. It works in both. So the moral of the story is you're going to have to write some equations. You're going to have to check and see which answer is correct in both equations. And you might guess the first time and get it wrong, and that's okay. But you got to make sure that they work in both equations. Substitute into both equations and check.